around, if you rewrite a plus bi, if you write it as a, what we were doing before, like in its polar form, so a plus bi, which can be written as some kind of r cosine of theta plus I sine of theta. Remember doing that in the other lesson? All right, then the different roots are given by the nth root of r and then times cosine of theta plus 2 pi k all over n plus I sine of theta plus 2 pi k all over n. So do you think I'm going to have you memorize this? No, because I just had to go grab a book to remember it, right? So obviously there's an easier way, and that's what I was saying. A lot of math teachers only teach us formula, and they don't show like that there's a pattern with this. There's definitely a pattern. Okay, and you would have to plug in k equals 0, 1, 2, 3. So if you were going to the 8th root, you would have to plug in 0, 1, 2, 3, 4, 5, 6, 7. And you would write all 8 of those answers. Okay, so it's going to be a little time consuming. So it says, luckily for us, there is a shortcut for finding all the solutions quite quickly. Okay, so let's think about the 5th roots of this number. So let's first change it into its trigonometric form, okay? Or polar form, whatever you want to call it. So if we're doing that, we're going to have r is going to be the square root of negative 16 root 2 squared plus negative 16 square root of 2 squared.
I forgot about I.
I don't need an I. Why do I not need an I? So I don't need an I because it's always just a squared plus b squared. It's in the form a plus bi form.
I knew that.
You're just going for that bonus point, aren't you?
Uh-huh.
All right, so we get r equals 32.
Wow, that's so smart.
And then theta, what do you guys think theta is without even doing any work? Just thinking about the picture? It's going to be this way, right?
It's going to be 240.
Oh, actually, maybe, hang on.
225.
180. 225, yeah. 225 degrees.
That's actually working. Yeah.
So if we are finding the 5th roots, so this is our z, what we want is we want the 5th root of z, and there are 5 solutions. Right, just like I did on that last question, right? If I was finding x to the 6th minus 1 equals 0, there were 6 solutions to x to the 6th equals 1. All right, so we would have 5 different solutions. So what the book tells you to do is to take the nth root of r, so we're taking the 5th root of 32, so we get 2, and we're going to have then cosine of whatever our theta was, so 225 plus 2 pi, I guess I could say 360, right, since I'm doing it in degrees.
To what degree?
Right? So I'm going to have plus 360 times 0 all over n. So in this case, n is going to be the 5th root, so it's 5. K, I know it's confusing because k and n. And then we would do the next one, so we'd have plus I sine of all that. Right? And we'd find that. So that first solution is going to be 2 cosine of whatever 225 divided by 5 is. So 45 plus I sine of 45. That's the first solution. So what we would do is we would write that as like z1 or something like that. So we'll write it as the first solution, z1. And then you would do it again. And you'd plug in 1 for n. And you'd keep, or not n, 1 for k, and then 5 for n. Do you guys understand what I'm saying? And you would do it again, and again, and again, until you have 5 solutions. Okay, do we want to do that? No. Okay. So what we do is we find the first solution. So our first solution, so tell me if z is equal to, well, let's draw this first solution. So did we find the first solution? So we have 2 cosine of 45 plus I sine of 45. Do we know where that solution is? It would be 2 units out along the 45-degree line right here. All right, and then we always take our 360 degrees and divide it into n pieces. So in that case, that's n equals 5. So what is 360 divided by 5? Anybody know that?
360.
70.
74.
72. All right, it's 72. So what we do now is we go from that solution and we're going to go out 72 degrees for all the other ones. Okay, so basically you're taking the 45 degrees and you're going to add 72 to it, and then you're going to add 72 to it, add 72, add 72, add 72, okay? So until we get 5 solutions. Do you guys understand that? So we're going to have Z2 is equal to 2, I'll write it as CIS. Do you guys remember the cosine plus I sign? Of what's 45 plus 72?
That one number.
What number?
74.
What are you talking about? You were killing me. Not 74.
116, isn't it?
72 plus 45 is not 74. All right, so 117. And then add 72 again. So you get 2 CIS 189. And then add again. And you get 2 CIS, what was it?
This isn't on the.
261. And then the last solution would be 2 CIS, added again, 72, 333. Okay, and those would be all of your answers.
Wait, how did you?
So what did we what was it?
What did we what?
So we're just adding the previous number before.
We're just adding 72 degrees because they're all going to be equally spaced. So if here's the drawing, here's what we would have. So in polar coordinates, so the first answer was right here. I'll draw it in red, right there. That's the first answer, right? It's saying go out 2 units, right? R equals 2, along an angle of 45 degrees. Do you guys all see that? You could find what that is as A plus BI form if you want to. How would you find it if it was if I wanted A plus BI form? Just multiply it in, right? All right, is everybody paying attention? I see people spacing out. So cosine of 45 is root 2 over 2. If I wanted to find A plus BI form, I would do 2 times root 2 over 2 plus I times root 2 over 2. That's what one of your last homework assignments was. So you would get root 2 plus I root 2. Do you guys see that? That's our first solution. Okay, I'm going to leave it in this trigonometric form or polar form. Now the second solution, the next one, is going to be 72 degrees past
Plus that one.
that. So if you add 72 degrees, you're over here somewhere, right? 117 degrees. But you're still out 2 units. And then I add another 72 degrees, so I'm over here at 189 degrees. And then I add another 72 degrees, so I'm at 261. And then I'm adding another 72 degrees, and I'm over here. And if you do it correctly, if you did it on polar paper, if you kept track of your angles really nicely, what happens? What shape do you get? You get a perfect pentagon, a regular pentagon. They're all 72 apart. Does that make sense? All right, so that finds the different solutions. So once you find the first one, don't waste all the time plugging back into the formula. Just keep adding whatever 360 divided by n is to your angle. Okay? So let's do another one. So it says find the 4th roots of this. So first step, you want to find it in the trigonometric form. All right, so our trigonometric form, we're going to find r. So I'm going to have negative 81 over 2 squared plus negative 81 root 3 over 2 squared. So we find that. Okay, use your calculator. Try it along with me. All right, what do we get?
We get that one number.
81.
81 is correct, yes.
It's up there.
You just looked at what I had it. All right, theta. You could sketch it out if you want. It is an exact answer. We'll put our calculator in degree mode though, because you guys like degrees better than radians. I get it. All right, so we're gonna do inverse tangent. Yep, you got it. Inverse tangent of the negative 81 root 3 over 2 divided by
Why do we have such big numbers?
negative 81 over 2. Because numbers aren't always nice in the world. I don't know if you've noticed that. Sometimes numbers are gross. So we're going to flip everything. So flipping the second one, the 81s are going to cancel. And the negatives will cancel. So that's gone, that's gone, that's gone, that's gone. So we get root 3. So if I do inverse tangent of root 3, on your calculator, it's going to give you 60 degrees. But you have to be smarter than the calculator. Because what quadrant should this be in?
The 1/3.
Alex, stop.
The third.
The third quadrant, yes, the third quadrant. So if I want it in the third quadrant, what am I going to add to it? 180. So your answer should be 240 degrees. All right, if you were really good with your 30, 60, 90 triangles, you wouldn't have to do all that work. You would notice that that's a 30, 60, 90 triangle. All right, so that means that if I'm trying to find the fourth root of z, there's going to be 4 solutions, right? So z1 is going to be the fourth root of 81 times and we're going to have cosine. I guess I need to draw it out. So I need the 225. Oh yeah, I just take my angle that I had divided by. So 240 divided by what? So fourth root, so 4. So I get 60. So that's going to be the first one, always. So I'm going to have 60 degrees. Well, 60 degrees isn't always the first one, but take your answer here and divide by n. So I have I sine of 60. So that's the first one. So if I was sketching it out, what's the cube or the fourth root of 81? Anybody know that off the top of their head?
3.
Yep, it's 3. So I'm going to have 3 cosine of 60 plus I sine of 60. And it's going to be, with the polar coordinate grid, it's going to be right here. Okay, that's the first answer. So what am I adding to each of those? Yeah, I'm just going to add that 360, or that 360 divided by 4. So I'm adding 90 degrees to each one because I want 4 solutions. So I'm going to divide the whole 360 degrees into 4 segments, 4 equal pieces. So when I do that, I'm going to have adding 90 degrees to 160 puts me at 150. Adding, so I'm going to write that one down maybe. So Z1 is that. Z2 would be 3 CIS 150. Z3 would be 3 CIS, right, cosine plus I sine. Add 90 again. 240. And then Z4 is going to be 3 CIS what? Add 90 again. 330. And if you do it correct, you should get a 4-sided figure where all the sides and all the angles are the same. What shape are we going to get? A square. So we're going to go out here and we're going to have 240. And then the other one's going to be right over here. And if you connect those 4 answers, do you guys see that you get a square? All right, that's how you can check that you did it correctly. So you find the first answer, and then you add 360 divided by n to each of those. Okay? No, it never will. Yeah. And that's another way you can check that you're right. If it doesn't, it should not go over 360 degrees when you're doing this. Okay, so do you guys see the pattern? All right, now if you wanted to find these all in A plus BI form, you would be able to find it in A plus BI form. I'll probably let you leave it in like polar form because that's like one more step, right? All right, so suppose we have the equation z to the n equals 1. We know that there are n solutions to this. These are called the nth roots of unity. The polar form of the number 1, if you have the number 1, it's 1 plus 0i. Because cosine of 0 is equal to 1 and sine of 0 is equal to 0. All right, you guys get polar form? Well, actually, maybe I should write it as, that's fine, the polar form, trigonometric form. All right, there we go. So the formula for the roots of unity then. See, I always have to look at the formula too because I always do it with a picture. Is going to be, what is the formula for that? Now I'm really going to mess it up. Okay, so let me just do the picture. All right, so if I have the eighth roots of unity. So what this is saying, and this is important because I remember in summer pre-calc, I put this on like the final, and people were like, what's it mean to be a root of unity? Right? All it means is that you're solving the equation x to the eighth equals 1. That's all that means. Eighth roots of 1, right? Unit circle is 1, unity is 1. You all know a solution to that. What could x equal? What is one solution that we all know? 1. All right, once you know one of the solutions, right here, we are going to take our 360 degrees and divide into 8 pieces. When we do that, we get 45 degrees. All right, that means from this answer, right, and you could draw your polar grid and all of that, but from that answer, we're going to go out 45 degrees for all the other answers. So we have, this is the first solution, this is the second solution, this is the third solution, fourth solution, fifth solution, sixth, seventh, and eighth solution. Okay, would you be able to write those? So with these roots of unity ones, I expect you to be able to write them in A plus BI form, because you know what? It's unit circle values. That's all you're doing. Roots of unity involve unit circle. So this first one is going to be the point 1, 0. So in, gosh, Kathy's so loud. It's going to be 1 plus 0i. Do you guys see that? On the real axis, imaginary axis. This next one is root 2 over 2 plus root 2 over 2i. You get it? They're all unit circle values. So what's the top one? Yeah, it's 0 plus 1i, right? The next one, negative root 2 over 2, man, what am I doing? Plus root 2 over 2i. Okay, the next one, negative 1 plus 0i. You see where I'm getting all these numbers? Yeah. Negative root 2 over 2 minus root 2 over 2i. 0 minus I. And positive root 2 over 2 minus root 2 over 2i. Those are the 8 solutions. So if you had solved x to the 8th equals 1, like we did in Algebra 2, and you tried to factor it, right? It would be kind of tricky with the x to the 4th plus 1. You would get 8 solutions, and those are the 8 solutions that you would get. Does that make sense? All right. So what if I had the 6th roots of unity? So that's saying solve x to the 6th equals 1. So if I'm solving x to the 6th equals 1, what's the first solution always?
1.
It's 1. You always put it there, right? 1 plus 0i. So we're going to take our 360 degrees and we're going to divide into 6 equal pieces to get 60 degrees. And we're just going to go 60 degrees for all the other answers. So the first one's going to be located there at 60 degrees. The next one's going to be at 120 degrees. The next one's going to be at 180 degrees. 180 plus 60 is 240. 240 plus 60 is 300. And if you draw it correctly, see how it makes the nice little hexagon shape. That's how you can test that you did it right. So then if we're coming up with the 6 solutions, can I write it as Z1, Z2, Z3? Or you want me to write them all the way around? I don't care. If you write them around, it's fine. I'll know that those are your solutions. All right, so the first one was the 1 plus 0i. This is our second solution.
1/2 plus square root 3 over 2i.
You got it, 1/2 plus root 3 over 2i. All right, what's C3? Negative 1/2 plus root 3 over 2i. Do you see how it works?
I see.
Negative 1 plus 0i. That's Z4. Z5. Negative 1/2 minus root 3 over 2i. And Z6.
Z.
1/2 minus root 3 over 2i. Okay, so those ones are easy. All right, last one. What if it's not nice? So what if you have x to the 5th minus 1? All right, if you have x to the 5th minus 1, the first solution is still 1, right? That's always the first solution on the roots of unity. All right, so we take our 360 degrees and we divide into 5 pieces. We just did that number. What number was it? It's 72. So we're going to go out from 1 and we're going to go over 72 degrees for all of these. So we're going to have the first one here. The next one's going to be at 144. Let me think about how to draw it. The next one's going to be at What was 144 plus 72? We just did all these.
117.
117. So let me write. Not 100.
Yeah.
You were killing me. I did hear you say you needed a nap. All right, 144 plus 72 is what? 216. And 216 plus 72 is 288. Thank you. My calculator just died.
Oh, I'm sorry.
I could probably do it in my head, but it's been a long day for me as well. All right, so we have all those. So those aren't the answers, though, are they? So this is where you would have to use your calculator to help you, because these are not like unit circle values, none of these except for 0. So this is where you'd have to write, like Z2 is going to be, you go out a unit of 1, right? 1, and then you're going to have cosine of 72 plus I sine of 72.
We write CIS.
Yes, you can write CIS if you want to. And you would find that. So you'd find cosine of 72. Maybe it's going to hang on here for a second for me. And you would round it to 3 decimals. So you'd have 0.309 plus sine of 72 is 0.951. 0.951I. Whoops. I1. Right? And then Z3 is going to be 1 cosine of 144 plus I of sine of 144. And then you would find both of those. Does that make sense? You get it? Do I have to finish that problem out, or you get the pattern? Good to go? All right. Any questions on any of that? So when in doubt, if you have some kind of root, think about a picture. I think that helps a lot on these problems.